Hello geometry students, and welcome to a lesson on distance and midpoint formulas. This is lesson 2-2b. You should probably write that at the top of your paper. Find this in your weekly packet. And let's get started. This is to prepare you for homework. This is in the packet right here. It's called homework 3. So prepares you for homework 3, but this is, like I said, this is lesson 2-2b in the module for week 2. Okay, so let's start out with the distance formula. Now later on, I'm going to show you some other ways to find distance in the coordinate plane once we've reviewed Pythagorean theorem. But for now, we just have this formula. And the formula is, you should recognize it, this is review. Distance equals that long square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so when we're looking at something in the coordinate plane that's slanted, we need to use the formula. So any oblique line, which is a slanted line, needs the distance formula. Any horizontal or vertical line, you can kind of just count. It's just a number line, so you can use what we've used in the past, which is the absolute value of the difference. Hopefully that makes sense if it's a straight horizontal or vertical line. Okay, but here it's not. So we're going to identify our x1. So this point right here has coordinates negative 5, 3. So what I'm going to call x1 comma y1, that is negative 5, positive 3. And what I'm going to call over here x2, y2, that is at negative 2, negative 3. So that's negative 2, negative 3. And we're just going to plug those numbers into their proper places in the formula, and that's how you use the distance formula. So d equals a long square root, and it says x2 minus x1. So if this is what I called x2, and this is what I called x1, I'm just going to subtract them. So I have negative 2 minus negative 5 squared. Now I do the same thing with the y's. So if this is what I call y2 and this is what I call y1, I'm going to subtract them in the other set of parentheses, just like it says to do right here. Okay, so I have negative 3 minus 3. Yes, negative 3 minus 3 squared. And let's be careful, because that's not 0, that's negative 6 squared. So what we have is we have the square root. It's going to be a little less long this time. Negative 2, now when we have subtracting a negative, that's really like adding a positive, right? Negative 2 plus 5 is 3, so this is 3 squared. So this is 3 squared, and then this one is negative 6 squared. 3 squared is 9. Negative 6 squared is positive 36. And this gives us the square root of 45. And that is approximately 6.7. Okay, and that's how you do it. Now if you want to take this a little step further, you might remember that the square root of 45 is not the square root of 9 times 5. So that's actually 3 rad 5. We're going to review that some more. So if you don't remember that, that's okay for now. Okay, if you don't have a graph, you can just use the points. We're going to make this x1, y1, make this x2, y2. And by the way, it doesn't matter which one is which. I'm going to pause the video. I want you to pause the video, and I'd like you to try to work it out, and then when you unpause the video, hopefully our answers will match. Okay, so pause it now. Okay, so hopefully you got about approximately equal to 7.3, exactly equal to square root of 53. Okay, let's try the same thing with the length of EF. You do the whole thing from scratch. Again, pause it. If you made a mistake on number 2, I would look that over first and then try number 3. Same thing, pause it, and then when you turn it back on, the answer will be here. Okay, there you go. Numbers are a little bit bigger on this one, but you should get about 18.7. And by the way, your calculator, make sure you do have a calculator that has a square root key. You can use your phones for that calculator. You can get a simple calculator online. There's lots of apps out there. So make sure you've learned how to use that square root key on whatever calculator you're using. All right, next is the midpoint formula. The midpoint formula uses the same x1, y1, x2, y2, and the midpoint is equal to an ordered pair. Now this is two formulas in one because you have to have something for the x, which is basically going to be the average of the two x coordinates. So if these are the two x coordinates, their average is x1 plus x2 over 2. And the average of the y coordinates. So if these are the two y coordinates, the average of those two would be y1 plus y2 over 2. And that's like two formulas, but they're identical to each other. They just use a different variable. Okay, let's look at the first example here. So we're looking for the midpoint of GH. I'm just going to call it MP for midpoint. And that equals the ordered pair, 7 plus 9 over 2. Now, if you want, when you're doing something simple like this and you think about it, the average of 7 and 9, that's 8, right in the middle. Okay? The average of -5 and -1, right in the middle of -5 and -1. If you can figure out what that is, you don't have to do much else. Okay? -5 plus -1 over 2. Right in the middle of those two is -3. So this is just going to be the average of 7 and 9, which is the same thing as 16 over 2, which is 8, and the average of -5 and -1, which is the same thing as -6 over 2, or -3. Now don't leave it like that. It's an ordered pair, so always put your ordered pairs in parentheses. So I don't think they're just two numbers. They're not just two numbers. They're an ordered pair. Okay, so it's important that you use the right notation there. Okay, let's try the next one. I'm going to pause it, and again, when I turn it back on, hopefully you will have the right answer and we'll match. Okay, it's a little bit harder to look at -7 and 3 and do that in your head and think, well, what's right in the middle of -7 and 3? So maybe to avoid that, just actually use the formula. So -7 plus 3 is -4. -4 divided by 2 is -2. On the other hand, it's very easy to think about what's halfway between -4 and +4, and that's 0, but it also adds up. So this is 0 over 2, which is 0. Okay? All right, let's look at another problem. Now this looks like it might not have come out right. I don't think this one came out completely, so I think what we'll do for this one, just skip it since it didn't show up on my printout. So just skip this. All right. So what we're going to be looking at here, and this is a different kind of problem, is we're looking at, we have the midpoint already. So find the coordinates of J if K is the midpoint. So now this already is the midpoint. That's what we've been looking for in the other problem. So we have to kind of go backwards and unwind this. And to think about unwinding it, what I want you to think about is when we put MP, what we really meant is there's some point xy that I'm going to call it x sub m, y sub m, which stands for the midpoint. And if you think about that midpoint formula that we have right here, if I put this as xm, comma, ym, because I'm really looking for an ordered pair, the xm, the x part of the midpoint, has to equal this part right here. And the ym, the y part of the midpoint, has to equal this part right here. So what we really have is the red formula and the green formula. We have two different equations that we're going to break them up now because we're going to have to work with them a little bit different. So we have the the red equation. I think I made the red equation x. So one of the equations here will be that x sub m is equal to, and what we had was x1 plus x2 over 2. So that's going to be the same thing. x1 plus x2 over 2. And the other part would be y of the midpoint is equal to y1 plus y2 over 2. Now let's think about that here. If we, by giving that a name, it kind of helps us here. We're looking for the other point. So if this is the midpoint, this would be my xm and my ym. I guess I lost my red and green thing here, so let's just go with red for now, okay? So xm and ym, and L, so this is segment JL, which means the endpoints are J and L. So L is one of the endpoints, so I'm just going to call this x1, y1. All right, so we've got these two ordered pairs, and what we're looking for, so we want x2, y2. Okay, so that's kind of reversing the situation here, and the way we're going to set that up is we're going to just plug in the numbers. So we're going to make, first we're going to find our x2 using the x part of the formula here. So we have our xm is -5, our x1 is -8, and we're looking for that. So we're just going to still call it, we're just going to call it x because it's our only variable now, and this is a 2. And we just need to solve that equation. So multiply both sides by 2, and we get -10 equals -8 plus x. Add 8 to both sides. Let me just write that underneath here. So plus 8 plus 8. And we end up with x equals -2. There's the x-coordinate of the point that we're looking for. That's the x-coordinate of the other endpoint, J. Now we're going to set up the same thing with the y. So my y sub n, remember y sub m is the one of the midpoint. You have to, I would underline the one that's the midpoint so you know where the m's are, okay? So the y sub m, we're going to use this formula now. The y sub m is 10. So we have 10 equals y sub 1. So y sub 1 I put over here as 6. So that's 6 plus the other y over 2. And we just have to solve that equation. Multiply both sides by 2 and we get 20 equals 6 plus y. Subtract 6 from both sides and we get y equals 14. So the other endpoint is -2, 14.